All right, so for this lesson, we're actually going to be looking at inverse equations. We've done inverses and we talked about what an inverse is, but now we're going to talk about how to actually find the inverse equation of a function. So a few simple steps. So the first thing is if you have the notation f of x, you want to change that notation f of x to y. Okay, and it's just going to help you when you're solving in just a second. Now, once you change the notation f of x to y, you are going to switch your x variable and your y variable. And then after you switch them, you're going to solve for y. Okay? Now, one thing to remember is once you've solved for y, make sure you do your notation as the inverse. So you can change it back to f of x, but you're going to do the f inverse of x. So really what we're going to do is we're just going to practice several problems on how to actually find the inverse. So none of these actually have f of x, but if they were, you would change that over. So I'm going to start by switching my x and my y. So this is now going to become x equals 3y plus 2. And in order to do that, we are now, in order to find the inverse, we're going to solve for y. So I'm going to start by subtracting 2. So I have x minus 2 equals 3y. And then I'm going to divide by 3. Now, I would prefer that you simplify. And what I mean by simplify is if I'm actually looking at this, I would divide my two pieces out. So this would be 1/3 x minus 2/3. Okay? So my inverse, my f inverse of x is going to be 1/3 x minus 2/3. All right? All right, so another option here. We have y equals 2/3 x minus 5. So again, we're going to switch our x and our y. So x equals 2/3 y minus 5. And we're going to solve for y. So we're going to add 5. And then I have x plus 5 equals 2/3 y. Now, when I'm dealing with fractions like this, I like to go ahead and multiply by the reciprocal. So we're going to multiply both sides by 3/2. And in doing so, that's going to cancel my fraction out. So I have 3/2x. And you can leave in parentheses or you can multiply it out. It's completely up to you in that type of situation. So that's going to give me 3/2x plus 5. But again, if you do simplify, that's okay. And if you distribute, make it 3/2x. And then 3 times 5 is 15. So plus 15/2. So either one of those will work. All right, so what happens when we start to get some square roots, some squares, some square roots, some cube roots, then all sorts of functions? So when I'm looking at this option here, I'm going to start by switching my x and my y. Now, when I look at this option, I can see that I have y squared. So that's telling me that I'm going to have to do the opposite when I get there. So I'm going to start by subtracting 5. So I have x minus 5 is equal to y squared. Now, this right here is going to give me the square root. I'm going to take the square root because the square root is the inverse of that value squared. Now, the only thing that you're going to have to remember here is you've got to do your plus and your minus. If you don't do your plus and your minus, it's not going to give you the full picture. So let me actually bring up Desmos so you can see what I'm talking about here. All right, so if I'm graphing in this problem, so let's first look at y equals x squared. And then I have plus 5. All right, so I have y squared plus 5. If I do y equals, and let's say I didn't do the plus and the minus, let's just say I did the positive. So x minus 5. You're only going to see part of that graph because you're not looking at both pieces. So we're going to have to do that minus and then the square root of x minus 5. And we actually talked about this in the previous video. And I'm going to turn it to the same color so we can see it is all one piece. And you should also be able to see that it is reflective over the line y equals x. Okay? So when I write my inverse, I'm going to make sure I do f inverse plus or minus the square root of x minus 5. All right, so for our next one, we have x equals y plus 3 squared. Now, I have to get rid of that square before I can actually do the plus 3. So again, I'm going to take the square root, but we're going to make sure we do plus and minus the square root of x, and then y plus 3. Now, at this point, because my the only thing that I took the square root of was x, when I subtract that 3, I need to make sure that 3 is outside of the square root. So I have plus or minus the square root of 3, and then minus 3 is on the outside. So again, I can look at this option here. So I have y equals x plus 3 squared, and I have y equals, so I have the square root of x, make sure it's on the outside, minus 3, and y equals negative square root of x minus 3. And again, you can still see that it is symmetrical over the line, or reflective over the line y equals x. And then, of course, I'm going to notate it with my inverse. All right, same situation here. However, this is going to have a restriction unlike the other one. So let's look at the original. So I have x plus 5. Now, when I look at this, I can see that my domain is going from -1 to infinity, and my range is going from 0 to infinity. Now, when I do this problem, we're going to talk about why this happens in just a second, but I'm going to state my domain and range. So my domain of the original is -1 to infinity, and my range of the original is 0 to infinity. That's going to be important in a minute. All right, so I'm going to start. I have the square root, so in order to, let me switch my x and y first. So if I'm going to solve for y, the first thing I'm going to do is I'm going to square both sides. So I have x squared equals y plus 5. And then I'm going to subtract 5. So I now have y equals x squared minus 5. Now, let's look at this new equation, this inverse that we talked about. Now, the reason that this is not going to work for us is because we have more to the inverse than there was in the original. We can't have that. We've got to restrict the domain here. So if we restrict the domain, remember the domain, the original domain was -1 to infinity. But when we do the inverse, we are going to carry that inverse with it. So we're going to restrict it so that it's 0 to infinity. Or we could say that x is greater than or equal to 0. So in this particular problem, if I actually restrict my domain here, and I'm just going to use that with the, I call them the squiggle brackets, but I'm going to say that x has to be greater than or equal to 0. I can now restrict that domain, okay, and I can see that it looks exactly like the other one and it is going to be a reflection over that line. So whenever you have like a square root and that domain is restricted initially, but then it's not restricted when you take the inverse, make sure you apply that restriction. It's got to continue on with it, okay? So that restriction was applied to the inverse. All right, and then for number 9. So you have to be very careful when you look at problems like this. So I can't do anything until I get this cube root by itself. When you have stuff being added or subtracted or multiplying outside of any type of square root or cube root or anything like that, you're going to need to move those first. So if I have x equals 2 cube root of y minus 7. So the first one I'm going to start with is the plus 7. All right, so x plus 7 equals 2 cube root of y. And again, we want this to be by itself, so now we're going to divide by 2. All right, and then I'm going to continue. I'm going to keep writing this over here. So I have x plus 7 over 2, and then I have the cube root of y. So we're down to the last piece. So just like if we have the square root, we square it. If we have the cube root, then we're going to cube it. So now we have y equals x plus 7 over 2 cubed. So let's look at the original. So y equals 2, and if you want to do a particular root, you can go to the function menu, and it's going to be there. We can put a 3, and we have x. Make sure outside you put minus 7. So there's that cube root. And then I have y equals, and my new one is going to be x plus 7 over 2, and we're going to raise that to the third power. Now again, all I have to do is graph that line and see if it holds that reflection as a true statement. I can pick 2 points and verify that they are correct. So this one is at 0, negative 7. The inverse is also at negative 7, 0. All right, so change the notation. If you have f of x to y, switch your x and y and solve. All right, the last thing that I want to talk about is graphically. What do I do if I have an inverse? So when I'm talking about an inverse, we talked about the fact that it's a reflection over the line y equals x. But we also can talk about it being what we would call 1 to 1. Now, 1 to 1 means that my original function is my original equation is a function, and the inverse is a function. So if it's 1 to 1, it has to pass the vertical and the horizontal line test. The original graph has to pass the vertical and horizontal. So an example of this, if I have a line here, so I'm going to draw a line, all right, and my line, if I take it and I drag it, see that it does not pass the horizontal line test. All right, so I'm going to draw another line that's vertical, and I can see that this line right here, it passes the vertical line test. So the original is a function. All right, so the original is a function. Okay, now that is because it passes the vertical line test. However, this one right here, if I can select it again, there we go. It does not pass the horizontal line test. It doesn't pass the horizontal line test because it hits the graph at more than 1 point. So the inverse is not a function. So since the inverse is not a function, this is not 1 to 1. All right, so let's look at 11. So I'm going to use those same vertical lines and horizontal lines. So if I look at my vertical line and I move it across, I can see that it does pass the vertical line test. So since it passes the vertical line test, my original is a function. Now with my horizontal line test, so with my horizontal, I can see that it also passes the horizontal line test. So since it passes the horizontal line test, my inverse is also a function. Well, since they are both functions, this function is 1 to 1. Okay, so that's what it means to be 1 to 1. It means that I have no repeating x values and no repeating y values in my table, my graph, and a map, any of those options, okay? All right, if you have any questions about inverses, please let me know.